This is going to be a presentation on decentralized blockchain service providers. Should be a D there. Specifically the ipfs-bch wallet service code repository on GitHub. That's what I'm going to talk about. This is a project overseen by the Permissionless Software Foundation, and the broad stroke is that this provides Bitcoin Cash wallet services over the Interplanetary File System, or IPFS network. So that's a highly censorship-resistant network. Web apps that you build and can run on IPFS can access the Bitcoin Cash blockchain and other blockchains. And so I'm going to give a quick demo, very quick demo, just to show you how quickly and easily you can start interacting with this technology, that it really exists. But I'm going to spend the majority of this video discussing the high-level implications of this technology and sort of the roadmap where I go from here, and where the Permissionless Software Foundation goes from here with this technology. If there's any audio problems, please forgive them. I'm not in ideal conditions. There might be a little bit of background noise, but I'm just going to do my best with this. So let me just give a quick demo. This is chat.fullstack.cache. I've given it a minute to load, and I've done other videos on what this app is. It's a developer tool. These are different services. What this web app does is it starts an IPFS node in the browser, and then it reaches out using a library called IPFS Cord to start a subnetwork. And these entries here are all different service providers in this subnetwork with me. And so right here is the one I'm going to demo today, ipfs-bch wallet service demo. And here is the API documentation. I'll spend a little more time doing this, going over this in a little bit. But right now I'm just going to copy one of these JSON RPC commands. I'm going to paste it in here, and the service is coming back. And what I'm doing is I'm requesting information on a Bitcoin Cash transaction. That's the transaction ID. And what it's doing is it's giving me back information on that transaction. There's inputs, there's outputs, there's the hex representation of the transaction, all this information about the transaction, how many confirmations it's been, the block time, if it's a valid SLP token transaction, which it's not, the block hash of the block that contains the transaction. So basically, this is pretty standard information, and for about a transaction. And what I want to draw your attention to are these 5 calls under the JSON BCH area. So there's balance, get a balance, broadcast a transaction, get information about a transaction, get a transaction history for an address, and then there's get UTXOs about an address. These are really the 5 most critical calls to the blockchain that a wallet would need in order to make transactions and just perform typical functions in terms of spending money, spending tokens, getting information about things on the blockchain. There's a lot of other stuff, but really these are the 5 most critical pieces of information that any wallet app needs. And that's what this provides. So I showed really quickly how to give a JSON RPC command and then get data back using the JSON RPC over IPFS. So that's the demo. If you want to play with it yourself, you can go to chat.fullstack.cache, and if you want the API docs, I'll go over this again in a minute in a little more detail, but it's at ipfs-bch-wallet-service.fullstack.cache. So what just happened? What just happened in this demo? In terms of it happened really quickly. It's probably a little unclear as to what the value of it is. So let me talk about just mechanically the software, what happened, and then I'll go into these very high-level implications that are implied by the existence of this software, the fact that the software exists right now. So the cache stack is a idea. This is fullstack.cash. This is the web service that I operate. It sells Bitcoin Cash blockchain access as well as eCash blockchain access as a service. And this cash stack is a core idea behind that service where there's a stack of software involved in building any application that interacts with a blockchain. In this service particularly focuses on Bitcoin Cash and eCash, but this basic architecture is the same for every blockchain, where you start with a full node, that's the lowest layer of the software, and then the next layer are things like indexers, which are like little search engines that crawl the blockchain and pull out other data that's not immediately available. So in the case well, I don't need to go in more detail than that. And then there's BCH API, which is a REST API maintained by the Permissionless Software Foundation that wraps these so that developers don't need to know any specific details about this stuff. All they need to know is the API, one API documentation set in order to interact with the API. And then if you're a JavaScript developer, we have BCH.js, which is a JavaScript library for interacting with REST API. Everything in this stack is open source and MIT licensed. There are pre-synced databases and Docker containers that we offer, and so anybody can set this up. This is all 100% open source. Anybody can run this on a home network if they're willing to put in the time and teach themselves the skills in order to do it. And the Permissionless Software Foundation is here to form a community around this software and help people run this kind of software. We're blockchain agnostic, so we tend to focus on Bitcoin Cash, eCash, and Avalanche, but we're open to any blockchain. And so what you just saw is this one more layer on top of this cache stack. And chat.fullstack.cache is a web app, and it is running an IPFS full node inside the web app, and it's communicating over IPFS to this IPFS BCH wallet service, and which is largely wrapping this stack. So the IPFS wallet service is kind of like a server, except it's just a node on IPFS, so it's no longer really a server, and it is providing Bitcoin. It is providing access to the blockchain and then piping that data over IPFS to an app like this. So one implication is that this app can run natively on IPFS. This is you could pull this up in an IPFS gateway, and everything that you're seeing here would operate, and these back-end services would now operate over IPFS too, which means the entire stack of software running here lives in IPFS and gains the censorship resistance of the IPFS network. So just mechanically, that's kind of how the stack works for the developers out there. Hopefully that didn't make your eyes glaze over, because what I really want to talk about is the high-level implications. And the two, if you focus on any slide in this talk, this is the slide to focus on. This is the most important slide. Basically, the first one, any IPFS-based web app can interact with any blockchain. So what do I mean by an IPFS-based web app? Well, chat.fullstack.cache is an example of that. I'm actually just going to go ahead and open this up. This might take a minute to load. It is faster using the conventional Web 2.0, URL type stuff, but this entire web app will load as a binary blob on IPFS. And well, I won't let that. I'm not going to wait for that to load, but you get the idea, where this web app can live entirely in IPFS without any sort of server or any type of location that can be censored, accessed anywhere on the globe, and now it can interact with the Bitcoin Cash blockchain. And this same scheme applies equally to any blockchain. IPFS-bch wallet service, this could easily be forked for eCash or the Lotus blockchain or the Avalanche blockchain or Ethereum or BTC, whatever your favorite blockchain is. All it really needs to do is expose whatever these basic wallet functions are, and then an app like this can be built that can live entirely within IPFS. And so that's the first high level implication. I think that's a really big takeaway. But the second big takeaway is even bigger. This is huge in my opinion. Any computer in the world can sell services to any other computer. So, for example, this right here, ipfs-bch wallet service demo, this is running on a cloud VPS. It's got good connection. I'm paying for it, and then of course there's this whole cloud connected cache stack, which I pay quite a bit of money every month to maintain, and there's a lot of overhead there. This is the exact same service, dash DSL, and it's running on a average desktop in a shed at a residential house using a residential DSL connection. And I just communicated it with the same availability as this high-end server here. And because it's IPFS and we use circuit relays, all of the networking is just automatically handled. I didn't have to do anything. I didn't have to worry about firewalls. I didn't have to worry about SSL certificates. I didn't have to worry about a DNS name. I didn't have to worry about port forwarding. I didn't do any of those things. I ran the exact same software, which is just a Docker container, and it's equally available. And so the ease of the networking and the ability to run this same software in a sort of a hobbyist or a home setting and have it compete on par with professional web services is huge. It's huge for decentralization. If decentralization is one of these overused words, but it's overused because it's important, and it's a heavily nuanced concept. But it is important. If you got into Bitcoin for the original reasons that Bitcoin was created, as a censorship-resistant money, decentralization and censorship resistance go hand in hand. More decentralization means more censorship resistance. More censorship resistance requires more decentralization. So this is a huge step towards decentralization, where professional services can be run at home, and the networking just sort of goes away. It's no longer a problem, and people can sell these services and make money at home. I'm going to talk to that in a little more in a minute when I get to the features. But again, if you focus on anything in this presentation, these two high-level implications are the biggest thing to take away. That any web app, I mean, you want to talk about serverless. This is true serverless. There's truly no server. If I was building a wallet app, a decentralized wallet app, I could have it pick one of many different redundant services. I could one of the things I plan to do is have a web app eventually that can do this and find all the different wallet services on the network, and then find the one with the best price, and then choose that one. And that can all happen automatically on the fly at startup without any interaction with the end user. And so, again, this is a big step towards decentralization, of being able to run an app that can't be censored and then connect to back-end services that can be offered by any computer in the world and have a robust marketplace of competing services. And so these I just really need to spend a minute on this slide and have you internalize those implications. But let's go ahead and move on to some of these other concepts that are really important to understand what this is and what the implications are. So this is the classic diagram of network topology that's taught like in Computer Science 101. There's centralized network, which is how most of the internet works. So if you imagine Google right there at the center, or Facebook right there at the center, and these are all the users, and that's why deplatforming is so effective, is because if they decide to cut this line, you don't have any choice and you're cut off from the rest of the network. This is a fully distributed network. This would be the opposite of that, where if one of these nodes gets lost, it's not a big deal. All the other nodes just route around it. This is how the internet is supposed to work. And it does at a very low level, like TCP/IP. And this is how IPFS works. It's a fully distributed network, and that's the core idea behind the decentralized, censorship-resistant properties. Um, yeah, so I'll just leave that there. And so it's really common to talk about client server. This is called the client server model, where like Facebook is the server and your web browser is the client. And this is how virtually all web apps are built today. And we're moving more towards a consumer service model, where that's what this technology is. Some of these nodes are service providers, and most of these nodes are service consumers, and they're simply nodes in a fully distributed network, and they're negotiating the best price. They're putting the different a web app might be putting together more than one service in order to achieve a business goal. And so that's what this technology represents, is a step down that road to move away from the client server model and towards the consumer service model. Okay, so code and documentation. The documentation lives at ipfs-bch-wallet-starter.fullstack.cache, and that's what I was looking at right here. This is the documentation. There's both a REST API and a JSON RPC. REST API is provided kind of as a redundancy. You can certainly, this is a full-blown production-ready microservice. So you can resell your access to fullstack.cache right now today using this code. Anyone can call these REST API endpoints, but I'm much more excited about the JSON RPC, which goes over IPFS. It's the exact same endpoints, but they're accessible over IPFS. And so IPFS is replacing HTTP, and the JSON RPC is replacing the REST API. It's a drop-in replacement for those technologies. And then the code is on GitHub under the Permissionless Software Foundation GitHub group. And the repository I'm focused on in this video is ipfs-bch-wallet service, which is actually a fork of this IPFS service provider. This is the boilerplate that I started with, and then I just added the Bitcoin Cash specific endpoints, those 5 endpoints. That's the only difference between this and the IPFS service provider. So if you want to, say, fork this and build your own similar blockchain service for your favorite blockchain, you would fork this boilerplate and just add the blockchain specific endpoints for your favorite blockchain. And then you can start selling access to your blockchain over IPFS. So that's the code and the documentation. So just some of the features. There's a simplified menu of calls. That's again a really big feature of this. Is I've been trying to get developers interested in BCH.js, which is a very full-featured JavaScript toolkit for working with Bitcoin Cash. However, because of its flexibility and breadth, it's actually overwhelming. And so I thought, okay, well, I'll start this project with just these 5 core calls. These are the I created wallet.fullstack.cache, and I've created several wallets. SLP Cly wallet, I had a Hand and Badger wallet. So I have a sense of like what the basic requirements are for a wallet, and there's actually not very many calls a wallet needs to make when it really comes down to it in order to have the basic wallet features or to build an app that interacts with the blockchain. It's really just these 5 calls. And there's a lot of technology that goes into these simple calls. But they're here, and that's really all you need. So that's a big feature, the simplified menu of calls. There is consumer example code. So let me just dive into the code real quick. Well, actually, that's actually a good. There's 100% test coverage. So if you are interested in selling web services over IPFS, you can start with this boilerplate. It's a great thing to start with because it has 100% test coverage. That's a great place to start from. Very few projects offer 100% test coverage. But just real quick, as an example, if you go into the test directory, there's unit call tests and then there's end-to-end tests. And in this manual consumer, there is a simulated consumer of these JSON RPC calls. So if you want to create your own wallet or some other thing to consume these services, this is a great place to start. This is all the code that you can copy and use. So here's an example of starting the IPFS node, connecting to the the wallet service, sending a balance transaction, getting information on a transaction, or checking the balance of an address, and then there's more code in here. But that example, that test code, is a great place to start if you are a developer and you want to start consuming these services and doing something with them. They're great examples of how to talk to the Bitcoin Cash blockchain using this new JSON RPC over IPFS. And then finally, there's this JOT token, JSON Web Token. It's a standard. This is what fullstack.cash uses to sell access to the blockchain service. And so if you want to know more, I suggest going to fullstack.cash and looking at the pricing and going to the examples page. And there's a video there where you can learn more about JOT tokens and how fullstack.cash uses those to sell access to its REST API. So those are the main features. Going forward, here's just a very rough roadmap because this is a new project. It's just getting started. But I need to take those end-to-end tests for the consumer and actually build a JavaScript consumer library so that people can just drop a JavaScript NPM library into their app and just start consuming these services. And then from there, I'll probably create a command line interface wallet. So if you're familiar, I'm Chris Troutner. If you're familiar with my work, you'll know that I created the SLP CLI wallet, which is a command line wallet for rapidly prototyping programs on the Bitcoin Cash blockchain. It's nice because it doesn't have a graphical user interface, so you can prototype much faster. And then once we get that going, we will take that same code and roll it into a web app. So something very similar to chat.fullstack.cash. Right now, all these wallet features, they use the REST API, so they still use the centralized way of doing it. And so that'll essentially be this third goal will be to get to a web wallet that is like centralized mode and decentralized mode. You flip a switch and you go from centralized mode to decentralized mode. Spins up an IPFS node, connects to a wallet service provider, and then bam, all of a sudden your web wallet is using a decentralized service for everything, and that means, particularly if you load it over IPFS, it's available in every corner of the world, including behind the Chinese firewall, probably even behind Turkey, where they close the internet off, which is really hard to shut it off completely, so sometimes there's a leak. And any sort of repressive regime, this is a great way for, in Russia, they have pretty strict laws around cryptocurrency. These types of web apps are one of the ways they're getting around government rules like that. Then I need to port the JOT payment code. I'm already getting interest in this of making like a turnkey service that you can sell. It's not a priority for me, but it is very important, and the code already exists in BCH API and JOT BCH API. It just needs to be ported over. And then I also want to fork this for other blockchains. I'm thinking eCash, Avalanche, and Lotus would be the ones I'd start with first, and then grow out from there. But really, since I'm looking at this roadmap, I invite you to collaborate with me. If this excites you, especially these two high-level implications, if these excite you, then you're the type of person I want to work with. Especially if you're a JavaScript developer. Please come join the Permissionless Software Foundation community. Our website's psfoundation.cash. We have a Telegram channel. That's where most of the action happens. I'm also going to start a Gitter or some other web-based channel because a lot of people don't use Telegram. And if you want to reach out to me directly on Twitter, my handle is @ChrisTroutner, and then the Permissionless Software Foundation is @PSFDAO. So please reach out, learn more about this. This is earth-shattering technology in terms of moving the ball forward for decentralization and true decentralization, making cryptocurrency and cryptocurrency apps truly uncensorable.